Hey, good morning. Thanks, y'all. Thanks for coming. Really excited to have you all here. First Learn Lab of the day. Cool. So I'm excited to talk to you about this topic personally. It's a personal tech passion area of mine. I think observability is really cool. So today we're going to cover, as it's on screen right here, deep observability insights at any scale with Consul. So why is observability an important topic? Why care about it? Observability is pretty cool because with it, you can improve performance and identify bottlenecks and transaction timings across your distributed applications. You can debug your distributed services faster and with precision. It's easier to drill down into errors that you're identifying with the metrics or logs. You can also improve resilience in your applications by using metrics and logs to anticipate problem areas before they happen by analyzing trends. So to sum it up, what we don't see can impact us and our applications in unknown and unexpected ways. So it's important to increase our awareness of what we care about as much as possible in these systems. What's great about Consul is that it comes with a number of built-in features that will help empower you and your various teams at your organization with this information with minimal setup and minimal configuration. Okay, so who am I up here on stage? My name's Eddie Rowe, and I'm going to hit the mic. Sorry about that. My name is Eddie Rowe, and I'm the lead product education engineer for Consul. Our team, the education team, we design content for you and for others to guide you along your learning and development journey. We don't work in a vacuum, though, so I want to give a huge shout out to the different teams, the education team at large, the engineering team for Consul and development, the sales engineering team, and marketing for all the work done on this behind the scenes. It's been a huge collaboration, and I love working with the group of people that I work with, so it's absolutely fantastic. All right, yeah, speaking of sales engineering, we have Patrick Presto here. Patrick is in the room. He's one of the wonderful TAs today. As Justin was mentioning, we also have Sujata here on engineering, and we have Vinu here as well. Vinu? Maybe we don't have Vinu here. Maybe Vinu will be here. Okay. Oh, he's coming. Okay, cool. So we have some, hey, there's Vinu. All right, so we have some wonderful TAs here. Together, we're going to work together to help as many folks as we can throughout the session. Now's a good time to also say that if you have any questions throughout the session, feel free to write them down. We've got some notes and paper, or most of you probably have laptops here. Write them down when they pop into your head, and we're going to take some breaks throughout this session to answer as many questions as we can. So if we don't get to your questions live today, then find me after the session or hit me up on LinkedIn on here. And just as a caveat, I don't know everything, not even close, but I will do my best to get you the information that you need or that you want. And knowing that many of you work with Consul at a much larger scale and in different environments that I do, I'm sure there's a lot that I'm going to be able to learn from you. Okay, in this session, we're going to walk through the scenario that's laid out in the tutorial at this link. So go ahead and visit this URL now so you can easily copy and paste all the commands for this Learn Lab. And if you're in this room, don't worry about reading all the introduction and all the context and all the words. I'm going to be covering all of that in this presentation today. Ideally, you've completed the prerequisites for the workshop and prepared your terminal to run Terraform, so we can jump right into it. If not, no worries. The prerequisite instructions are in this tutorial, and take just a moment to set up. As a heads up, this lab involves cloning a GitHub repository and spinning up cloud resources in AWS. If you don't have the ability to create resources in AWS, that's okay too. Feel free to hang out with us here, and you'll see the entire workflow up on the screen. Or you can check out your neighbor's screen if they're cool with that. Please ask. There's definitely value to be gained either way by being in here. So in regards to the resources, we'll be spinning up a small EKS cluster and some supporting resources. We're going to show you some diagrams on the screen here soon that give you a summary of these various resources. If you'd like to check out the diagrams ahead of time, they're also in the tutorial. And you'll hear me say that a lot. It's also in the tutorial. So in terms of the format of this lab, this is our intro and spin up portion. Then I'm going to talk about the context of lab while it's spinning up and the resources are spinning up. Throughout, I'll be taking some question and troubleshooting breaks with me and the TAs. Then we'll dive into just work through the main procedural portion of this lab and wrap everything up as tidy as possible. Okay, so before diving into the context of this lab, let's go ahead and clone our repository and run Terraform to get our lab building. If you don't feel like typing this in, just do what I'm going to do and head to the tutorial, and you can easily copy these commands throughout this. So head on over to your favorite repos folder and wherever you have Git configured and run these commands that you're probably very familiar with. I'm going to do it as well. So again, the URL for this lab, hashi.co. And you can also search for this in our developer docs too, if you missed the short link. So I'm going to zoom in a little bit. I'm going to zoom in a lot a bit. And I'm going to scroll down to the Git cloning section here. And just in case you'd like to keep looking at the prereqs or you're still installing these, that's all in this section right above. But what I'm going to do is I'm going to copy these two commands to clone our Git repository. And then I'm going to change directory into that repository. OK. I'm also going to look that up and just ground myself here with the README file. OK. Now I'm going to go back, and I'm going to grab this command because I like copying commands. It makes my life easier, and change into that directory. Then I'll do a little bit of cleanup. OK, so once your clone finishes, basically you'll see that this repo contains a lot of Terraform files for this lab. The Terraform deployment is going to take about 10 to 15 minutes once we start it up. So that's going to take us to the end of the content and context portion of this presentation. Then we'll get started with our fresh environments and run through the procedures together. I'm going to move back to the presentation screen. Here we go. OK, so cloning. We've done that. We're working on that. Now we're going to start the Terraform deployment once we're in that path. For this environment, I default to the US West 2 region. I find it has a pretty quick deployment time relative to some of the other regions, especially where we are right now geographically. But feel free to change that to the region of your choice in your variables.tf file. And I'm going to show you quickly just where that variables.tf file is in our repository. And if you notice here, I have it set to US West 2. But if you only have permissions to do it in another region, go ahead and switch it to that one, or any other region of your preference right here, and then save the file. OK. If you see a failure that happens for any reason while you're spinning up Terraform, it starts to go through the init and the apply there, and you see some failures, just rerun Terraform apply. And it's rare that it'll happen. But hey, if there's a Wi-Fi blip that happens or something gets stuck, just rerun Terraform apply, and everything should spin up and build right on top of that. For those of you who haven't used Terraform as much, it's essentially 3 points of contact with the terminal once you've set up your CLI and your AWS authentication. We're going to run Terraform init, run Terraform apply, and then we're going to say yes to the plan that comes out. So let's go ahead and do that now. I'm going to scroll down here. All this is in the tutorial. Told you I'd be saying that a lot. I'm sorry. So I'm going to run Terraform init here. And this is going to download the providers. It's going to download the different modules that are in here, including the EKS module. And it's really going to set up the backend for Terraform so that it runs successfully when we run our Terraform apply. OK, I'm going to go, while this is setting up, I'm going to go back to the lab and scroll down a little bit. And I'm going to grab Terraform apply. And if you're curious about exactly which providers, you'll see a list here. But you can also go in the providers.tf file. And you can scroll down through here and see the providers AWS, Kubernetes, Helm, this kubectl file. I know pronouncing that's a source of contention, random stuff. And you'll see that laid out in here. Okay, so I'm going to close this down. It should take just a moment. All right, so yeah, like I said, it's going to build for about 10 to 15 minutes once we run this. And then we're going to get into some diagrams and context. Also, don't worry if you're not right in step with me right here, like you're still setting up the prereqs, or maybe you're just coming into the room and checking it out. As long as you get to that HashiCorp 2023 tutorial and are running through stuff, we're going to be pretty close in sync. And I'm also going to have some natural question breaks and buffer time to allow the resources to continue spinning up. So like I copied from the tutorial, I'm running Terraform apply right now. And the first thing that this is going to do for those folks relatively new to Terraform is that this is going to tell me that I'm not authenticated with AWS. That's what it's going to do first. And so I'm going to authenticate with AWS. There we go. Those are my fun little shortcuts. Okay, we're going to run Terraform apply again. It's still telling me I'm not. Oh, well, sorry. Okay, live troubleshooting. Nothing like that in the lab. Okay, verifying I'm in the correct directory. Verifying everything looks good on here. It says my signature expired, so I'm going to just open up another new directory here, and I'm going to change back into that. And I'm going to re-authenticate with AWS using our organization credentials. Okay. Well, I hope no one kicked me out of the organization. Okay, so I'm going to go over and I'm going to do a little troubleshooting here. And while we do that, can I get a show of hands to show, is yours running successfully? Are you successfully authenticated? That is great news. I'm jealous. Okay, so we're seeing a very, very fun error today. But, I planned for this contingency right here in case something weird happens on my end. So I have a backup Terraform state file here. I'm going to go through this. And I'm going to use this. And this has the complete resources spun up for me already. But if I'm the only one with AWS credential problems, that's a good thing. Okay, so I'm going to pretend at this point that mine's running, even though that backup one is already up and running. And I'm going to keep moving through the presentation while this builds for the rest of you. Okay, so let's get started on some content. My objective today is to do this, is to show you how to use Consul to give your application and support teams insights into your distributed applications. Zooming out for a moment, according to the CNCF, in regards to the definition for observability, observable systems yield meaningful, actionable data to their operators. You, your application team, support teams, allowing them to achieve faster incident response, increased developer productivity, less toil, and less downtime. It all sounds really nice, right? Who wouldn't want that? But more specifically, who can this information be useful for? If you perform the role of a platform or infrastructure engineer, there is solid value for you in this lab with a control plane observability section where we'll dive into metrics and logs for your console clusters. We understand the platform team helps the application teams and support teams' lives easier. So by abstracting and you can do this by abstracting the secure service-to-service communications and the observability responsibilities from the application teams and the application layer itself. You can provide exponential value to these teams and your organizations by doing that. And I'm not on the presentation. There's what you were missing. Okay. So now that you know who I am and that I hit the mic a lot and how we're going to get there, to guide you through the build, I'll give you a brief overview of what we're going to accomplish. Then I'll dive into the procedure to achieve our mission. So in this Learn Lab, you will troubleshoot a distributed application, a service mesh application, our demo application called HashiCorp using Consul. You will use metrics and logging. You will enable those features that provide insights into the health and performance of your data plane and your control plane, which you will explore with a common bring your own observability stack, Grafana, Prometheus, and Loki. First, you will use these features to diagnose and troubleshoot traffic problems with the data plane. Then you'll use these features to explore the metrics and logs of your control plane, the self-managed console cluster that we spin up. Finally, you will see how HCP Consul centralizes and simplifies observability and visibility for your console clusters and services across your entire org. And that kind of segues into the topic of bring your own observability suite and HCP. Bring your own observability suite being like the Grafana stack we mentioned, or that could be Datadog or something else. The two aren't in this Street Fighter versus each other kind of situation. It's more of a cooperative gameplay kind of situation instead. So Grafana and Datadog, where they shine in terms of complexity and a wide breadth of possibilities and configurations and customizations, HCP Consul observability shines in regards to the simplicity and the centralization of the console service mesh observability. For platform teams that are managing, monitoring, and observing clusters and services across entire organizations, maybe some that are self-managed, some that are HCP managed, some that are in different cloud environments or on-premise, HCP Consul provides a centralized location for that visibility and observability. And you can easily scope out and share that visibility and observability with the respective teams that may get the most value from it. So we're going to see both in action today. We're going to start with the Grafana stack, and then we're going to move into the HCP observability suite. So let's talk about exactly what we'll be seeing on each of those platforms. To build a clear mental model of this topic, we're going to break things up in a little more bite-sized pieces here, some manageable buckets. In this lab, you'll see how we can enable and then visualize each of these components in this slide here. Spoiler alert, it's basically with Helm chart parameters and some Grafana dashboards. So to be specific, in this scenario, we're going to collect metrics and logs for each of these buckets here to visualize the health and performance. We'll also see dashboards that provide information for troubleshooting and for debugging, as well as auditing our service mesh applications and service mesh control plane. Now you may say, from the observability gurus in here, hey, Eddie, where are distributed traces? Where's continuous profiling? What about that? What's up? And I'd say it's very observant. Good job. Gold star for anyone who did that. So the reason we're strictly going to focus on metrics and logs involving these console features is that these features require no additional configuration or instrumentation at the application level. So that means just by the nature of your application being in the service mesh, with the console observability features enabled, you're able to immediately get value and insights from your data. So that's quick control plane insights for platform engineers to gain console cluster health awareness, and that's also quick data plane insights to provide your application developers and support with performance information for the various distributed applications in your organization. Observability stuff, cool, right? I think it's cool. So let's do a quick console one-on-one on the control plane and data plane. So we have some context about where this information is coming from. I'm going to take a sip of water because I'm talking a lot more than a remote worker usually talks. OK. For some of you, this may be your first time interacting with the service mesh. So let's take a super quick moment to demystify it. Here we have the classic model of service-to-service communication. It's the classic case of your web service talking with your API service talking with database, whatever the case may be. Here you can see the two services communicating with each other over standard network traffic. The challenge this architecture faces is in regards to efficiency, scalability, and security. It requires these challenges to be handled programmatically by the application developers in addition to their primary application duties. So this is most likely not their specialization, and if incorporated into each application, it may not be the best practice, maybe in a different language, may not be updated, and it may not be standardized across all the application teams. So enter the world of service mesh. The first core aspect of service mesh is that rather than talk directly to each other, services utilize sidecar proxies to communicate. This is known as the service mesh data plane. You may think, hey, why do we go through sidecar proxies? Well, I can just have the services talk directly to each other. And the answer is, like we were referencing in the challenges before, it helps solve those challenges of efficiency, scalability, and security. And it does this at a level that abstracts the responsibility and the integration away from your application developers. So they can focus on their individual application logic and business logic and what they specialize in, rather than these important mechanisms. The sidecar proxies also provide a vast amount. And when I say vast, like, it's no understatement. I'll show you some of the Envoy metric databases later in documentation. But these proxies provide a really large amount of data plane observability information that we'll explore together today. So the proxies do all this work, but how do they get the configuration and policy information to work as a cohesive distributed system? OK, enter the control plane. This is the function of Consul clusters. This is what they do. The control plane controls how traffic is managed, routed, and processed through the service mesh. Without the Consul control plane, the sidecar-enabled proxies are essentially just little secure island fortresses that are unsure of who they can talk to and where those services may be. With the Consul control plane, you decide which services talk with each other, how they fail over other data centers, and many more aspects of your mesh. In regards to which services can talk with each other, Consul controls that with a Consul concept called intentions. Intentions are configurable at layer 4 or layer 7, giving you complete control over service-to-service communication, kind of like a firewall. This control plane also contains a large amount of observability information that reveals the health and performance of your Consul clusters. And we'll be covering that today as well. So to summarize, the data plane moves the service-to-service traffic, and the control plane tells it how and where to move that traffic. OK, so now we've done a quick service mesh rundown. Let's take a look at how you can utilize Consul observability features to get insights into your distributed applications. And we'll begin by applying the concepts that we just learned in this Consul one-on-one session. Real quick, these couple slides, and that simple architecture to the architecture that we're going to use for this lab. OK, well, our environments are still spinning up. Let's talk about some of the details and the traffic flow of this particular scenario. Here we have a bunch of rectangles and symbols denoting various components of our scenario today. The exterior blue rectangle represents our EKS Kubernetes environment, while the interior gray rectangles that you see represent the different Kubernetes namespaces in our environment. In the Consul namespace, up in the top left, we have our Consul cluster, which takes on the role as the control plane for our service mesh. And the observability namespace in the top right, I'm pretty sure that's the orientation on your screen, we have a typical open source observability stack. That was, as we mentioned, Grafana, Prometheus, Loki, and Promtail as well, which we're going to use to collect and visualize our metrics and logs from both the control plane and the data plane. Finally, in the default namespace, the big rectangle at the bottom, we have our microservice-based demo application, HashiCorp. Within the lower HashiCorp's gray rectangle, you can see that each of our HashiCorp's pods encapsulates the service itself, like public API with that cube, as well as the sidecar that runs the Consul data plane process and the Envoy processes. This sidecar is called the Consul data plane in Kubernetes and runs in each of your pods that utilize Consul. These Consul data plane sidecars receive their respective policies and configuration from the Consul control plane, as denoted by these solid pink lines here. Like we touched on before, the Consul control plane is what configures these sidecars to turn HashiCorps into a distributed service mesh application. Should change? There we go, it changed. All right, yeah, once the Consul control plane sends each data plane the configurations necessary to turn these individual HashiCorp services into a distributed service mesh application, each service will only communicate with the other services through the secure Consul data plane. The Consul data plane traffic can be seen here by these dashed pink lines, which denotes the communication moving from proxy to proxy between the services. So now that we've built up the elements of our tutorial, let's shine a quick light on the traffic flow of the demo application, HashiCorps. It's pretty straightforward. So a client HTTP request, that could be you or a computer, is sent to the HashiCorp service, which is handled by the Consul API gateway, as indicated by the gray dashed line in this diagram. The API gateway is the intelligent ingress gateway for our service mesh applications that will route the request to our HashiCorp's microservices. Down the line, after API gateway, Nginx will route the traffic to two different paths. Route, which goes to the front-end microservice, and then /API, which goes to the public API microservice, and then to the rest of the microservices downstream. Again, all this communication is happening via the Consul data plane, that dashed pink line. So as for observability information like metrics and logs, the observability suite scrapes that information from the Consul data plane and control plane. And we'll see more about how it does this in the next slide. Quick note, there's also a pod that's not pictured here. It's called traffic in this environment, and it generates network traffic for HashiCorps. And it's going to make our dashboards look a lot less flat and a lot more interesting. So also, you can see there's quite a few resources that we're spinning up today, which is why it takes 10 to 15 minutes to build this out with Terraform. So thank you for your patience. OK, now that we know about the general relationship between the pods in each namespace and how HashiCorp's traffic flows, let's take a quick look at the observability flow, specifically how the observability suite scrapes metrics from the data plane and the control plane. The elements to notice here are the observability suite on the left and the representation of our Consul servers and HashiCorp services on the right. In the next slides, we'll talk about the interactions between these elements. So once observability features are enabled, how do Prometheus and Loki and Promptail know where to go hunting for the metrics and logs? Well, in a Kubernetes world like this one, the first stop is the Kubernetes API itself. Prometheus and Promptail essentially ask the Kubernetes API, hey, where are the scrapable metrics and logs that I can start gathering? And the Kubernetes API says, here you go. These are the services that have the appropriate annotations and the information available. Once Prometheus and Promptail complete that scraping endpoint service discovery, they get right to work. In the case of Prometheus, it scrapes metrics from each of the Consul servers on port 8500 at this V1 agent metrics path. It also scrapes every Consul data plane sidecar on port 20200 on the /metrics path. So the top one is how it's gathering the control plane metrics, and the second one with the sidecar, port 20200, is how it's gathering the data plane metrics. As for Promptail, it scrapes logs from the Consul servers at standard out and standard error. It also scrapes logs from each of the Consul data plane sidecars at the same location, essentially gathering logs for both the service mesh control plane and the service mesh data plane. Promptail then pushes these logs for both the service mesh control plane and data plane into Loki, which stores them and makes them very nice to query. Finally, we'll see all this nicely displayed information in Grafana, which we'll access through an AWS load balancer that spins up as part of this Terraform resources. We will basically enable these features in two configuration files: the Consul Helm chart and the Consul sidecar proxy defaults file. We'll see all these details in the lab, and they're all in the tutorial. Okay, so that's a lot of me talking, a lot of context right there. While the deployment continues to finish up, I'd love to see a raise of hands. Whose resources have finished spinning up? All right, cool. We'll probably need a little more time if some others are waiting. Who's just watching the workflow up here, hanging out with a neighbor? Cool, nice, let's hang out. Awesome. So now we'll do two things. Our TAs will go around and help any folks with deployment issues while I hang out up here and answer any general questions at this point. So yeah, we have Patrick, Sujata, and Vinu. My name's Eddie. If you want some TA help, just put your hand up and look towards them to get their attention. If you'd like to ask me any questions, let's do a thumbs up in the air so I know how to distinguish between the two right there. It is 11:05. So just want to take a note of that. We'll do this for a little bit, and then we'll hop back in. So this is not the last question break either. We also have question breaks at each Consul upgrade. So with that, we have any thumbs up question? Sorry, yeah, can you throw that in the microphone?
Yeah, can an observability suite be used without Kubernetes? And if you're using Nomad on the back end as opposed to Kubernetes, can that be set up that way?
I'm not sure about Nomad in that case, but I know for sure with EC2 in a VM environment, absolutely, the same features are available. It looks a little bit different, like the setup and configuration. Sorry, these lights are very blinding. The setup and configuration are a little bit different, but I will get you the answer to that.
Yeah, that'd be great.
Afterwards.
Thank you.
Yeah, absolutely. Do we have more questions? I'm going to do the scan this way here. Thumbs up questions on stage. Stage questions. Okay, cool. Cool, and again, the TAs can help with any deployment issues that go on. So it is 11:05, and in the interest of time, I'm going to keep on rolling through here. Let's do stuff together. Let's do some stuff up on screen. If at any time you miss something I've typed, or something that I've clicked, don't worry, everything is in the tutorial, which is exactly what you're going to see me use throughout the lab today. Also, as a heads up, I'm going to put my acting hat on for the diagnosis and troubleshooting portion of the lab. Like I've never experienced the error before. I helped design the error. I'm sorry, excuse my bad acting. So I'm going to put the scenario diagram up here for now, but I'll be hopping between the tutorial and VS Code to run through the tutorial. Okay. Okay, so here's our scenario. I'm going to move over here and scroll down. And the first thing that we're going to do is connect to our infrastructure. So we have this nice string here that's going to use some of the Terraform output to connect us to our Kubernetes environment. So I'm going to move on over to VS Code. Oh, no. Bless you. If that's not working on that one, I'm going to try grabbing my other terminal. Oh, thank you. I did just change over to Pacific time. I appreciate that. Oh my gosh, I think you've solved it. Okay, I'm changing my date and time. There we go. Live troubleshooting, yeah, that's my favorite. Ah, thank you. What's that? Teamwork. Yeah, it's beautiful. Oof, I'd be sweating up here otherwise. Okay. Great. So I'm connected to the EKS environment. I've gone too many screens. I'm connected to the EKS cluster. So the next thing I'm going to do is configure the CLI to interact with the Consul data center. And that's with a few of these environment variables. The first one is the Consul address itself. So we have these nice handy commands that I'm going to copy. The next one is the Bootstrap ACL token. And finally, you wouldn't do this in production environment because I'm going to set the HTTP SSL verify to false here, but this is useful for the demo environment. So perfect. Okay, now I'm going to run the Consul catalog services CLI command to print all the known services that Consul knows about. This is also going to make sure that we're able to speak with Consul, which is a success. This is what we're expecting to see. Clean up my environment a little bit. All right, scrolling down a little bit more. Okay, cool. We've done some setup, a lot of setup stuff. Now we're going to enable Consul data plane observability features. So these, the full Helm file is in the repo that you've cloned for these right here, but these are some specific callouts that enable the metrics here. This one will enable metrics for Consul servers and clients and agents. This one enables displaying metrics in the Consul UI, and this one enables metrics for the proxy sidecars. And we have a lot more information about these in terms of the Helm description and different features that you can enable here in our documentation, which is linked right below this section. So I'm going to run this upgrade command that's going to enable those features. Okay. Oh, I've already cleared. That's just a habit. Perfect. Okay, so this could take anywhere between like 3 to 5 minutes to run, doing the upgrade in this portion. And so I'm going to pull up the Helm file here and just show you. There's no smoke and mirrors this section. You know, here's that metrics piece that's being added right here. And here's the other for the UI that shows some cool metrics in the Consul UI. And here is the last component down here for the sidecars, for the proxy sidecars. Okay, so this is going to keep going. Take a question break while this finishes upgrading right here. Does anyone have any questions about enabling Consul observability, or any observability questions? Let's just open the floor. Do another thumbs up. Cool, 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 cool. If you do, if something like comes up in your head afterwards, or you want to talk in more detail, just find me after the session, and we'll sit down together. Awesome. So that just finished the Helm upgrade. So the next thing that we're going to do is we're going to enable data plane logging. So that was a bunch of metrics information that we've enabled. The next thing we're going to do is we're going to enable access logs on the proxies. So in order to do that, basically this is the only line that needs to get added at this point. And I'll show you that file as well over here. So under config, we have the proxy defaults YAML file. And here you can see we're basically just changing this and enabling it to set those access logs to be exposed and emitted by the Consul proxy. Okay, I'm going to make the CLI a little larger here. Okay, so I'm going to apply these proxy defaults. And so in regards to these proxy defaults, this is great for all new proxies that are spun up. Any existing proxies need to be redeployed. So that's exactly what we're going to do. Scrolling down a little bit, we're going to restart the sidecar proxies for our HashiCorp app. So I'm going to copy that command from there and paste it in. And all of these will start to roll out the new deployment. And you can see in here that that old deployment's going away and that the new one is coming back. The new one is coming up with the new proxy defaults that have access logs enabled. OK, so yeah, basically at this point, Prometheus is going to be scraping the endpoint at /metrics. And it's also going to be Loki and Promtail are going to scrape the logs. So now let's check out the demo application and see what's going on here. Oh, that's not where that goes. That goes into the CLI. So I've got a nice string here that's going to basically emit our custom DNS entries for HashiCorps. And I'm going to hop on over. This one's not opening in the right browser. Here we go. I'll open it in this browser. This is where I want it. Oh, we are unable to query all copies. OK, so there's my bad acting. We're expecting this error at this point. And what we're going to do is we're going to use the data plane observability features of the console to diagnose this a little bit. OK? So, oh, there's my tutorial. OK, so now we're going to hop into the different dashboards in Grafana. The first one's the logs dashboard. And we're going to see how this one can be used to give us some more information about troubleshooting this problem. OK, so I'm going to paste this into my CLI. This is going to emit that custom link for us right here for each of us. And I'm going to open this link. It's also opening in a browser on my screen here. I don't know how to direct it to this browser. But it's OK. We're going to paste it in. And this needs to be zoomed in on. There we go. OK, so what is this showing right here? This is showing a collection of information from the proxy access logs for each of the different apps. And we are on the Nginx app right now, taking a look at that. And something that basically pops out is that there are a lot of 503 errors that are going on. So that's suggesting that the service is unavailable somewhere and Nginx not able to speak with something in the service mesh. So I'm going to filter out by those 503 codes and come down here and just check out in the logs, like, what's going on? So if you scroll down and you look through some of the information here, you can see that post requests are being made to /API, but it's getting a 503 every single time. If we go back to our slides, oops, you can see that /API is a request from Nginx to a public API. So communication is not happening there for some reason. And the next one that we're going to look at is so that's logs, information you can get from the access logs. The next one we're going to look at is some information from the metrics that are being emitted by the sidecar proxies. OK, so I'm going to paste this in here. It's going to take us to a different dashboard in Grafana. And let's see what's going on with some of the metrics. OK, we can see right away that something's up. We only have 5 out of the 6 HashiCorp services that are being registered in the mesh. We can also see on the side here that there's also some different, more 500 errors that are popping up on here. And we can look down here and see that public API does not exist in the downstream connections. So it's starting to suggest that public API is not in the mesh. In addition to these 2 dashboards, there's another dashboard, and I'll go there through the tutorial. There's a performance dashboard that we have as well. And so this is going to give us a slightly different perspective of the metrics. And just as a note, all these dashboards, these are custom example dashboards that we built for the purpose of this lab and for showing these things. your environment's going to look a lot different. Feel free to use some of these dashboards and these examples for inspiration. There's a lot of inspiration out there to grab, but yeah. And there's also a lot of metrics to see as well. So I'll show you that list shortly with Envoy and what gets emitted. But you're going to be able to make your own dashboards based on what you need exactly. OK, so we saw that health one. Let's go check out performance to see what different perspective that gives us. This one gives CPU usage by pod right here. And looking down into it, you can see that basically there's just little usage on some of this, barely, maybe none being reported because it's so little. And then on the network section, there's very little network activity. So I think at this point we've identified something's up with public API, and we need to go take a look in our infrastructure to see what's going on. OK, so let's restore the HashiCorp's functionality. Without giving it away by scrolling down too far, I'm going to just run, to check out what's going on with the pods. OK, and we can see here that the majority of the pods within the service mesh that are considered HashiCorps, the majority of them have 2 pods, which means they have their service container, service container, and they have their sidecar container. But this one only has 1 running. So something is going on with public API. So let's take a look at the YAML file, our deployment for public API. Well, OK, somebody on the team, they were doing some testing on here, and they said, hey, we don't want a sidecar proxy for Consul connected to this. It was set to false. So I'm going to set this back to true, and I'm going to restart the deployment to get a sidecar proxy on public API. OK, so I'm going to redeploy public API with the new configuration. And I'm going to give that a moment to spin up. Beautiful. OK, good. We just want 1 public API. I saw 2 for a second. OK, so now I'm going to go back, and I'm going to check out, hey, is HashiCorp working now? Awesome. Yeah, then without even refreshing the page, immediately we can see that the front end and the back end of HashiCorp is now functioning correctly. And we can go buy our favorite HashiCorp branded coffees and check out. So cool. That was the Consul data plane that we saw. And that was us using the Consul data plane observability features to basically pull some insights and do some troubleshooting. And again, that's with no application level integrations and nothing that needs to be done on that layer right there. So I want to take this, since we just did the data plane at this phase, I want to take this moment for questions about Consul's data plane or anything else on observability so far. Cool. OK. I anticipated there might not be questions. But because of that, I can show you some other cool stuff. So I mentioned the custom dashboards. It's going to be your own kind of environment. Everything is going to be custom for your. What can you build with is what I want to show you. So this link is also in the documentation right here to the different metrics that are available. And so I'm not joking when a lot of statistics are available for scraping and for your different metrics and dashboard designs on this right here. There is a lot of information here. There's descriptions of this information. All of this is being emitted by the sidecar proxies. So feel free to explore these pages just to get some more ideas, for yourself to see what things that you may want to build for your particular environment and your particular applications. OK, that's not where I want to be. This is where I want to be. OK, we've done the Consul data plane. Now we're going to move into the Consul control plane. OK, so in order to enable this, we've already done part of it. This stanza that we enabled before, the previous one, this starts to emit, enables the feature for the console servers to start emitting those metrics. There's also, this part is new down here. This is where we're going to configure the console server logs to emit trace level logs, which is going to do everything. It's going to give us trace, debug, info, warn, error. It's going to give us all the logs that come out of the console servers. And Promtail and Loki are going to be the ones that scrape that. Up here, I want to show you a little bit of the dev world, and demonstration world metric scraping. So this metrics are only exposed on port 8500. So in order for Prometheus to scrape them, we have to expose port 8500 on the console servers. Since this is a secure console environment, it has TLS enabled, ACLs enabled, 8500 without this entry is not open. So we're going to do this for demonstration purposes. Down in the notes, a little bit lower, in a production environment, you would use Prometheus Exporter, which, let's see, I'll get down there. We have Prometheus Console Exporter, and that would be used setting up this with the proper certificates and TLS information in order to export that out of console to whatever observability system you want. So this is a little bit of demonstration hack right here. Okay, so we know what we're going to change to enable this, so let's go over and do it. I'm going to copy this command to upgrade console again. And I'm going to go ahead and paste it in. And this is going to, once it finishes, it's going to take about 3 to 5 minutes to wrap up. Once it finishes, the control plane metrics and logs will be available to be scraped. Okay. Other questions? More questions? Question? Sir? Oh, did you need some individual help? Or?
Should I wait for the mic?
Oh, gotcha. Yeah.
So I noticed there's different levels of logging here. Is that configured on a reactionary basis based on storage and whether or not you need to troubleshoot something specifically, or or are you always having it at trace, or is there sometimes you just want it at warnings and that sort of thing, or is this specifically for debugging?
Yeah, no, that's a good question. By default, it's set at info, so it only has just a few minimal level logging that comes out of it for the purpose of the demonstration and just to show kind of the wider availability of what the possibilities of what you can get from a console server. I set it to trace here just for those purposes. But you would consider in your own environment what makes the most sense for you in terms of storage or what you find interesting. And something like trace can be really useful if you're having problems with your console servers. Maybe they're getting hammered and you can't figure out, all the metrics seem to look good, but maybe there's something else going on at a lower level. So this is for that deep debugging. That's a good question.
Thanks.
Yeah, thank you. Any more questions? Oh, perfect.
Hi, about the command we executed before, can you go back to the terminal?
Oh, yeah, sure.
So you have -- version 1.21. What version is that? Is that the console version you're using right now, or what is that version setting it?
Oh, yeah, this version right here, 121, corresponds to the Helm chart that I'm using.
Okay.
And so this Helm chart has specific values for what console image version to use by default. In this case, it's 1.16.1. There's newer ones. I think 1.2.2 is coming out. 1.3.0 is coming out. That'll use console 1.17. So each Helm chart has different default values attached to it.
Okay. Yeah, thanks.
Yeah, sure. Thank you.
Hello.
Hi.
This is David, product manager for Consul. So I've been sitting in.
Sorry, David, didn't see you.
Yeah. I just want to reiterate. So 121 is a version of Consul on Kubernetes. We have a Helm chart associated with it. For each stable release of 1.2 or minor version like 1.2, 1.3, 1.4, we associate that with another minor version of a console. So 1.2 correlates to console 116x. 1.3, which just went out today, the RC, you can try it out. It correlates to 117x. And so you shouldn't try to deploy, let's say, 1.3 on 116. Like, you don't mix and match those versions. You stay on the versions that they're tested against.
Thanks, David.
And yeah, if you have questions about console, please just come by and ask me questions.
Thanks, David. Appreciate that. All righty. Great. Any more questions in the meantime? OK, let's generate some more questions. Let's see. OK, cool. So the upgrade finished. So now we should have the control plane metrics enabled in this environment. So let's keep on scrolling down here. So Prometheus, the reason we're about to update this anonymous token policy is that Prometheus is trying to scrape a secure console server environment. And it does that when you're not using the Prometheus console exporter. It does that with the anonymous ACL token from console. And so, again, this is more demo environment testing level right here. You'd use the Prometheus console exporter for a more production environment. But what this is going to do is it's going to say, hey, allow things that have the anonymous token to read the metric information from the console servers. OK, so and here are the details of that policy that I want to show you. Out of the box, these two are part of the anonymous token policy. The ones that I added for this to enable that metrics to be able to be scraped are these. A policy to read for the 3 console servers that are in this environment. OK, so I'm going to apply that policy. So Prometheus is able to scrape those metrics from the console servers. All right, so that may take a couple moments, but oops. My goodness. Sometimes swiping with 2 fingers versus 3 fingers gets a little weird. OK, so we're going to explore those metrics and logs on Grafana with the dashboards. So we move on down here. We can grab this handy-dandy URL, or thing that will generate a URL for us. I'm going to grab this right here, and this should take us to our health and performance monitoring dashboard for the console servers, our console control plane. And so I'm going to zoom in a little here. Oh, wrong one, this one. OK, what you'll notice is this is from a dashboard that's publicly available at Grafana on their dashboards repository. There's a lot of information here to unpack. If we go to system stats, we can see some CPU usage here and some memory usage and what the limit that we have set at, the memory limit that we have set for our console servers. In the server behavior section, we can see the RAF commit times, which is some more details about how console is working under the hood. The important thing I think to take away from some of this is that all of these telemetry metrics right here, we have documentation, and it's linked in the tutorial as well, that describe the important parts about these right here, like what to look for, what's irregular. So some of this may be like, kind of just confusing to look at. Like, what does that mean? But all of this is described in that telemetry documentation, so you can put together custom dashboards and visibility for you to know exactly what's important to you in your console environment. Because, for instance, in this environment, some of these features may not be enabled, but they may be enabled in your environment, or may not be being utilized. Like the KV store right now is not being utilized. So dashboards are a very custom world. OK, so that's health and performance insights from metrics that are being emitted. Let's check out the event and error insights. Oops. So this is going to give us visibility into some of the logs. Go back here. So these are the control plane logs right here. And sometimes I beat this tiny instance of Grafana up, and I get these load errors right here. Sometimes it'll help if I set down to 5 minutes and stop refreshing so much. But what I want to call out here is that these are all the trace level logs and other logs that are being emitted from the console servers, being scraped by Promtail, put into Loki, and then being shown here in various pie charts or graphs to get a little more insight about just a different perspective on how Consul's operating. If it's experiencing any errors, what the different success error ratio may be for it, and then also the raw logs themselves. So if you'd like to filter through here for specific logs, it's a great central place to look for these type of logs. So platform team would absolutely care about this right here. There are more logs that, with the enterprise version, we have audit logs, and that's something that the security team may care a lot about for audits. So if you have Consul Enterprise, you can also scrape those logs and have those be put into dashboards as well. Okay. Cool. So before we get into the HCP section, let's do another break with control plane or other questions. Do we have any questions on this section or anything in terms of observability? Cool. All right, we'll keep rolling. Again, if you have other questions, just come find me afterwards or David, any of us afterwards. Okay, so the first thing that we're going to do here is we are going to link our self-managed console cluster that we've been interacting with to HCP. And you can sign up for a free HCP account here, but I'm going to go ahead and log into mine. And on yours, you may see it be a very fresh screen. Mine is a little more busy in here. So on yours, you may see just get started with console. So if you see that, go ahead and click that. Mine has some active projects. So I'm going to go into my console project here. I'm going to click View. And then I'm going to click to create or link a console cluster. And what I'm going to do is I'm going to click Self-Managed Console and then Link Existing. And this is all in the tutorial right here, so don't worry. So I'm going to click here. And then this is, you can have it read-write, so it can be an interaction back and forth, or you can just do a read-only interaction. So if you don't want that two-way street, that's a possibility now as well. Okay, so I'm going to come up with a naming convention. It's my console DC1 instance. I'm going to US West 2 because that's my region. I'm going to go over to EKS. And let's see what this gives us here. Cool. All right, so I'm going to select him because that's what I've been using for the rest of this project here. And then there's this little this little checkbox right here. Basically, this is, without it selected, you'll just be getting your control plane, your console cluster control plane information that's pulled into HCP and available from HCP to view. When it's selected, a telemetry collector gets deployed to your environment, which you'll be able to get control plane and data plane across your cluster sent back to HCP. So first, I'm going to grab this, and that's for this lab. In your production environment, you'd go through each of these instructions. But for this lab, we made it really easy in the tutorial. All you need to do is grab this first box right here and copy these credentials. And I'm going to move on over to my CLI. And I'm going to create these 5 secrets. All right. Nice. OK, so we have those 5 secrets right there. Now I'm going to move back to my tutorial and scroll down a little bit because we've done some clicking. And let's review what this Helm chart's how it's going to be enabled in the Helm chart. So this is also covered in the UI itself, but we're going to do a few things here. In the Helm chart, we're going to enable the Consul telemetry collector, and we're also going to put in this stanza that has the basically the link to the cloud here with these 3 secrets for our self-managed cluster collection, and then down below, these 2 secrets for the data plane telemetry collector. Okay, so let's go ahead and start the upgrade here. Move back to Visual Studio. I'm going to run through Helm upgrade. Okay, and this should take a couple minutes here to start spinning up and to connect everything. Now, after this finishes right here, the last thing that we need to do is we need to create intentions for the Consul telemetry collector to be able to get that information from your data plane and then send that up to HCP Consul. So we'll wait for that to finish. In the meantime, let's go take a look. Basically, as it starts to spin up and connect to HCP, this screen will refresh. It'll automatically refresh, as noted down below, and you'll start to see some of those metrics. So we'll come back to that in a moment. I want to go to one of the other active ones here. Oh, that one is disconnected right now. I think 2 pulled his lab. Okay, so cool. This is the one we are working with right here, and you'll see that the Consul server 2 is the first one to connect to HCP. And it's a couple different sections. This section's really nice because it gives you like an overview of this specific cluster right here. And if you want to manage the cluster, you don't have to go find that custom UI URL to go manage the cluster. You can go right in via this section once everything's connected and manage it directly from HCP. And this gets nice. I think this is really cool when you have a lot of clusters, especially when you have a mix of clusters. Some may be HCP, some may be on-premise, some may be in different data centers. This gets nice to help centralize and collapse a lot of that stuff as things spread out. Okay. Oops, should have just refreshed. So that'll keep spinning up. Another server's coming in. And as these servers are upgrading and restarting in our self-managed cluster, they'll be shown here. And then once those finish, that's going to start to fetch that information and bring it back over here. So let's take a look. Okay, cool. The Helm upgrade's completed. Now it's just going to take a few moments. And while we're waiting for everything to connect up to HCP, I'm going to go in here and I'm going to apply those intentions that we talked about for the telemetry collector to be able to bring those data plane metrics up to HCP. So I'm going to apply this. And those intentions have been created. Okay, and once the intentions are created, the last thing that we need to do in order to get that information to update the sidecar proxies is, once again, we need to restart the sidecar proxies so that with that updated information, they're able to send the data up to HCP. Oops. Okay, so I'm going to restart those. Okay, and as this is connecting, I want to show you, because this will just have a few metrics in it, I want to show you the page. Sorry, that's audit logging. Okay, so this is linked in the tutorial here, but this goes into detail about what information is visible on HCP Consul's observability pane right here, and it talks about what it indicates, what's useful, what's going to be displayed there. And HCP Consul stores up to 30 days of information in there for you to take a look at this. It'll go over leader transactions, some of these resources up at the top of this pane, but then it'll get into more details about, this has to be refreshed, more details about these type of metrics here, like host, similar to what we saw in Grafana, but this is for, this is all built-in centralized information right here. The host resource utilization, the server requests, the RPC connections, the same kind of metrics that we were seeing with Grafana, but within HCP. And another cool thing is that, so that's still going to be connecting. Oh, I did a hard refresh. Okay, great. So you'll start to see some of this information is going to start coming in. Another cool thing is that, so let's say you have tons of your self-managed services across your organization set up in here, or you have the mixed services, some HCP, some self-managed. You can click into the services pane over here, and you can search through those. Like, do you have the same service running in multiple clusters in different places? And you can see more of the details about those individual services. And so once the telemetry connector takes a little bit of time to set everything up, but once it starts pulling that data up there, you'll start to see information in here for each of those services in each cluster. So again, really cool spot to like centralize visibility. And then if you need to give permissions to certain teams for certain services or clusters, that's easy to delve out here too, to those teams. Okay. You'll start to see on your machines, it start to spin up, and you'll see more details on there as it gets a little bit of time to bring that data into HCP Console. Okay. So yeah, I want to do a bit of a wrap up and question portion here because we have a little bit of time left. Yeah, today, what did we see? What did we do? We covered quite a bit, went through the scenario, went through data plane observability, saw control plane observability, how to enable and utilize that, and then some HCP centralized observability and how to enable and utilize that. Most importantly, we saw a lot of cool dashboards with a lot of colors, right? And that's really what it's all about. It always makes me feel good. Okay, I know this was a long lab, and your time is valuable. You've got a lot of stuff you're doing today. I want to say thank you so much. Huge thanks for attending, for your patience, for your energy in here. It was awesome. This QR code and the link, it's going to take you to the same spot. It's the feedback survey for this lab and for the feature itself. So it takes just a few minutes to finish, and the engineering teams put a lot of weight behind this feedback for features that get prioritized and they get developed. So we'd love to hear from you. I'd really appreciate if you could take a few moments to fill this out on the way to your next session. Feel free to send it to your coworkers to get more feedback for this feature. Yeah, if you have any additional questions or you want to connect, feel free to find me after the session, message me on LinkedIn. Huge thank you for coming. Hope you have an awesome HashiCorp experience here in San Francisco, and have a great day. Thank you.